So, good morning, guys. For the students of Building Design 1, so our topic for today is all about the earth field. So, basic introduction for the earth field. When the first floor concrete slab of a building is raised from the natural ground line to a plane higher than the thickness of the concrete slab and gravel field, earth field is usually placed in the otherwise hollow space between on the ground line and the slab's gravel bed. So fill is also used to make level the sloping of an irregular terrain of the project site and for bringing about the desired grade of terraces, driveways, and etc. So an embankment of compacted earth is also determined as earth fill or can be identified as earth fill. So a composite material used in construction comprising a mixture of soil, gravel, broken rock, and etc. So usually earth fill is placed in layers not exceeding 150 mm in thickness and each layer is compacted by wetting, tamping, or rolling. So ang Tagalog ng earth fill natin, another term for Tagalog is the tambak. So yun yung tinatawag natin tambak. So examples of activity with regards to earth fill. So here is the example of the tamping activity. Then at the right side is the rolling activity. Then next, so for the earth fill, so how to estimate the quantity of the earth fill? So to estimate the quantity of filling materials required in earth fill, compute the volume of the hollow space to fill and multiply by 1.25. So to add 25% as allowance for compaction of the loose volume of soil to be delivered by the supplier. So for our formula, so volume of space fill times 1.25 or additional of 25%. So equivalent to volume of earth fill required. So after backfilling the excavations for footings, foundation walls, and other ground building parts or facilities, a considerable amount of soil and other materials is not used up. So the quantity of the material so recovered, which is used as fill, equals the volume of the footings, columns, foundations, wall, etc. buried below the natural ground line at the construction site. So for the example problem number 1, so estimate the earth fill of the one-story house as shown. So given the foundation plan and the longitudinal section of the building or of the house and the plan and elevations of CHB footing, column footings, and ayan. So, ayan. So let's get started. So in determining how much would be the volume of the earth fill required. So, Excel na lang. So to start, so estimate of earth fill for one-story house. Yeah. So based from our uh, procedure, so estimate the total volume of the hollow space to fill and multiply it by 1.25. Ayan. So going back, so for the hollow space in the figure, so sineperate na natin siya. So letter A for this part, then letter B for this part, C for this part, then D, and so on and so forth. So it means we are required to determine the volume of hollow space by different parts. So for letter A, so yeah, area of floor slab. Then next, so beside is units. So based from the figure, so letter A, so add na lang tayo. So A. So for slab A, so our area is 2.4 times 2.4. So yun yung ating area of floor slab A. 2.4 times 2.4. Ayan. Then next, so units in square meters. Then for slab B, so slab B, so 7.6, so itong part na to, and 3.75. Ayan, so 7.6 times 3.75. Then next, for C, for slab C. So for slab C, so to determine for the area of slab, so 3.9, so distance at x-axis is 3.9, and at y-axis is 3.6. 3.9 times 3.6. And for slab D, so distance for x-axis is 3.95, so 3.95 times 3.60. So, yeah. Then for slab E, so slab E, natin is equivalent to 2.25 times 1.2. So 2.25 times 1.2. So all units in square meters. So ayan. So next, so determine the volume of the slab or volume of space to be filled pala. So next is to determine for the volume. So volume of space to be filled with embankment. So the total area, natin, so total area is equivalent to 5.76 plus 28.5 plus 14.04 plus D plus E. So total area is equivalent to 65.22 square meters. Then next, so times natin siya doon sa height ng void to be filled. So ano ba yung void to be filled natin? So based from the longitudinal section, so the void space to be filled is equivalent to 0.85. So excess soil from foundation excavations not used up for backfilling. So ang height natin is equivalent to 0.85. So times 0.85 meters. So units, square meters, then ito, meters. So the total volume is equivalent to 65.22 times 0.85 cubic meters. Then next, so here is the volume of space to be filled. So 55.47 cubic meters. Then next, so punta naman tayo sa footings, columns, continuous CHB footing, and concrete hollow block unit. So, ang determine naman natin is yung volume of footings and walls below the natural ground line, which equals the quantity of soil recovered for the landfill. So, ito naman tayo. So, volume of footings and walls below the natural ground line, which equals the quantity of soil recovered for landfill. So, ayan. Dito naman tayo. So, ano-ano ba yan? So, footings. Then, yung columns natin, syempre, kasama yan. Then, next is the CHB footing or continuous CHB footing. And the concrete hollow block walls. So, concrete hollow block walls. So, ayan. So, going back to the figure, so based from the plan of column and footings, so volume of the footing is equivalent to 0.75 times 0.75 times the thickness, which is 0.3. So 0.75 times 0.75 times 0.3. Then next, so times na lang natin siya sa number of footing. So based from the figure, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ayan. So we have 12 footings. Okay, so 0.75 times 0.75 times 0.3 times 12. Tama ba? Times 12 pieces. Ayan. Then next, so for the columns, so based from the plan, so size of column is equivalent to 0.4 times 0.15 times, so height of the column is equivalent to 0.5 from the natural ground line. So times 0.5. So ayan. So siguro mamaya na lang natin pala ilagay yung number of pieces. So dito muna tayo sa volume. Cubic meters per cubic meters per footing, then per column. Then next, for the CHB footing, so size of the CHB footing based from the problem shown, so size is equivalent to 0.2 by 0.4. So 0.2 times 0.4 times length. So it is by total length. So what is the length of our CHB footing? So based from the foundation plan, so what lang tayo? So 10.3 plus 7.8 plus 3.95 plus 3.9 plus 3.6 plus 2 plus 3.75. So type natin. So 10.3. So I have my calculator. So 10.3 plus 7.8 plus 3.95 plus 3.9 plus 2 plus 3.6 plus 0.6 plus 3.75 plus next is 2.4 plus 1.2 plus 3.95 plus 3.9. So the total length is 46.75. 46.75. Yeah. Then next, so for the CHB walls, so size of CHB walls, so based from the problem, so CHB wall, so thickness of concrete hollow blocks is 0.15. So ito yan. So 0.15 times, so the height from the natural ground line is 0.3 times the length. So length natin based from the measurement earlier is 46.75. So ito is 3.74 cubic meters and 2.10375 cubic meters. Ayan. Then next, so for the total volume, equivalent to, so sum. Ito lang natin sum. Ayan, 6.0425 cubic meters. Then next, so next step naman, so ito per footing, then ito naman is per column. So it means, So, dapat pala, sinama na natin siya, no? Dapat times 12 ko na lang pala to. So, we have a mistake. So, dapat di ko na siya pinag-walay. So, times 12. And ito times 12. So, total number of columns is also 12. So, our total volume is equivalent to 8.22875 cubic meters. Then next. So, compute na natin yung remaining space to be filled. So, remaining space to be filled. So, to determine for the remaining space to be filled, so simply get the difference between the volume of space to be filled minus the volume of footings and walls below the natural ground line, which equals the quantity of soil recovered for the fill. So, remaining space to be filled, so 55.437 minus 8.22875. So, yan. So, cubic meters. So, it means, so yung ating remaining space to be filled is 47.20825 cubic meters. So, based from the principles of earth fill, so ang sabi, so volume of space fill times pa natin siya ng 25% as allowance. So, volume of earth fill required is equivalent to 47.20825 times 1.25. So, ayan. So, here is the required volume of earth fill. So, ayan. So, volume of earth fill required is equivalent to 59.01031 cubic meters. Then next, since we're done with the earth fill, so punta naman tayo sa gravel fill for concrete slabs. So, gravel fill for concrete slabs. So, usually, a concrete slab on fill is usually poured on a layer of gravel or any other approved coarse aggregate, so to provide a firm foundation. So, this gravel base, where so indicated in the plans or specifications, should not be overlooked when estimating the materials for concrete slabs on fill. So, its volume is equal to the area of the concrete slab multiplied by the specific thickness of the gravel. So, to determine for the gravel fill or the quantity of the gravel fill, so volume of gravel fill required is equivalent to, so formula, so volume of gravel fill required is equivalent to volume of space to be filled times, so times natin siya sa 0.1. So usually kasi ang ginagamit natin insight is equivalent to 100 mm. So times natin to 100 mm. So times 100 mm thickness. So ayun. So, volume of gravel fill required, so 65.22. So 65.22, or ito pala, so this is not volume of space to be filled. So total area to be filled. Total area to be filled equivalent to 65.22 times 0.1 meters. So the volume of gravel fill required is equivalent to 6.522 cubic meters. Ayan. So that's all for earth fill and gravel fill. Ayan. So thank you.